So in this video, we're going to look at the question from the Mulungushi University. This is probably on probability. So I'll go directly to the first question, and it says, a recent survey by the Public Accounting Association revealed 23% of students graduating with a major in accounting select public accounting. Suppose we select a sample of 15 recent graduates. A1, what is the probability to select public accounting? And 2, what is the probability 5 select public accounting? How many graduates would you expect to select public accounting? So this question is based on probability. And how do we solve this question? So you need to understand what probability model you are dealing with for you to solve this question. So one thing that can help you to understand the probability model is when we look at this question, we've got a number of trials. So I'm just going to put this on the next page. Look at this question, we've got a number of trials, and it says that this public accounting association has about or revealed the information that 23% of students graduating will choose public accounting. That is one scenario. They'll choose public accounting, and the second scenario is that they will not choose public accounting. So in the first place, we have, it can either be you choose public accounting, you say PA, and we can say this is a success, and we can call this is a success. And the other one is you cannot choose public accounting. We'll just say public accounting complement, and this is failure. So there are two possibilities in this scenario. It's either they choose public accounting or they don't choose public accounting. And if they choose public accounting, then the success rate for this, the probability of success of choosing public accounting, let's just label it as P, is equal to 23%, and I'm just going to write that as decimal number, decimal value, so 0.23%, 0.23, sorry, that is 23%, which is the probability of success. And then the probability of failure will be that it doesn't work out. Let's label it as Q, and that will be 1 minus 0.23. I'll just say 0.23, which should give me 0.77. That is the probability of failure. So you've got the probability of success and the probability of failure. So when you have got these two scenarios and you are leaning towards a binomial model, this is more of a binomial model. And one thing that shows us that it's a binomial model is we are dealing with suppose we select a sample of 15 recent graduates. So already we have got a sample or a number of trials, which we're going to label this as N. We're going to put this as N. So this is the number of trials, and this is the basically how many times we carry out this experiment, so number of trials. So when you have the number of trials and the probability of success and the probability of failure, and we assume that the events are independent of each other and the probability of success remains constant, it doesn't change. So this basically qualifies to be a binomial distribution. So if we want to find a binomial distribution, we can have a binomial model. We can say we have got, let's say, P, probability of the binomial model being equal to what is the probability that to select public accounting. So this binomial model has to be equal to 2, right? In the first question, which says what is the probability to select public accounting. So if the binomial model is equal to 2, then we we have the binomial distribution. Basically, before we even put this, let's just write it somewhere there. So the binomial distribution says that a general formula for the binomial distribution is that the probability of the binomial model being equal to R successes. We just say R, okay, for the number of success. Let's say R here is equal to the number of successes. So R successes is equal to the number of ways of getting these successes in the number of trials that we have. So we have 15 trials, and the way of choosing our successes from 15 trials, and I'll just write a general formula. So I'll just say n for trials, like which is this n here. So this is just a general formula I'm writing here. So n, number of trials, the number of ways of having r successes in the number of trials is just n choose r, and then we are going to multiply by the probability of success, which is p, and we'll just say this is p, probability of success, and then the number of successes we can have here is that. So this is the probability for the number of successes, and then we multiply this by and we have the probability of failure. Then the number of failures will be the number of trials. We have n trials minus the number of successes, which is that. So this is the general model of the probability, the binomial distribution. So let's use this model, and we have got here, what we have is the probability that the model is equal to 2. So we have got 15 trials, and we are choosing how many successes should be 2. Then the multiply by p, which is the probability for success, and we say it should be 0.23, and then we multiply that to the number of successes. So don't we raise the power at the number of successes, which is like 2, and then the probability for failure, we multiply this probability of failure, which is 0.77, and then we raise this to the number of failures, which would be 15 minus 2, and we can just put 13 here. Okay, if you want, you can say 15 minus 2, and then you go down. So when we complete this, we can just punch this in our calculator, and let's see what we get. So this will be somewhere 0.1860 as the probability that those guys, 2 of those people select public accounting. What is the probability that 5 select public accounting? We're just going to use the same principle. The probability that 5 actually select public accounting will be the number of ways of choosing 5 from 15 multiplied by the probability for success. Okay, so which will be 0.23, and then we raise this to the power 5, and we multiply this by the probability for failure, and how many if we have 5 successes, then probably out of 15, then that means 10 failures. So we'll just say 15 minus 5, and we know that gives us 10. So that is a 10, and then this should give us, this gives us 0.1416. You can just punch this in the calculator. So, and the next question says, how many graduates would you expect to select public accounting? So this is straightforward. So this is number 1, and this is number 2, and number 3. How many do we expect to select public accounting out of the 15? So the general probability is that in the number of trials, we've got divided by multiplied by the probability. The number of trials we have is 15, and then the probability for success we have, which is 0. So we multiply this by 0.23, and that will give us 3.45. so we expect approximately 3 should choose public accounting out of 15. So this is how you resolve this question. So just to recap, this is a binomial distribution and distribution model because we've got a constant number of value for probability of success, and we have got two situations. It's either a success or a failure, and we've got a certain number of trials. Okay, so this qualifies to be a binomial distribution, and then we just use the general formula for a binomial model, and we have the number of successes, the number of failures, and we just put into this model the general formula, and this is how we solve this question. Okay.